Hello students, let us begin with the next content of the chapter motion in a straight line. Till now we have learnt about the meaning of variables which we will use while studying motion of an object. Then we have learned about the kinematic equations, that is the equation which will relate these variables. Further, we will see its application level. To go with application level, we need to learn some more simple concepts in this chapter. So first is motion of an object under free fall. So what is meant by free fall? So object which is kept at certain height, at the initial it will be at rest and then it is thrown under the effect of what? Gravity. So it will be moving under the effect of what? Acceleration due to gravity. So the object which is there, it is moving in the downward direction. It is under the effect of force due to the earth. The acceleration possessed by the object when it is dropped from a particular height, that acceleration is called as acceleration due to gravity. So the value for acceleration due to gravity over the surface of the earth, it is equivalent to 9.8 meter per second square and it is denoted by the symbol small letter g. So since it is acceleration, it has the unit word meter per second square and its magnitude is how much? It is 9.8. And remember, the value for acceleration due to gravity, it is not constant, that is 9.8 as it has been given. Its value may differ when you are going at very much height above the surface of the earth or go below the earth's surface at very high depths. So it is found that the value of acceleration does not remain constant. But while we consider this chapter, we are taking into consideration the objects which are moving over the surface of the earth. And when we take surface of the earth, the value for acceleration due to gravity is supposed to be a constant and that magnitude is how much? It is equivalent to 9.8 meter per second square. Now, when the object is there, it has been thrown under the effect of gravity. It may be moving towards the earth or it may be moving away from the earth. The relations for the variables whichever we have learned may differ. So we will see those equations. First, take the case of an object which is there kept at certain height being thrown. At the beginning, it has initial velocity equal to 0. Object is falling down under the effect of gravity. The direction of motion of the object is the same as the force which is acting on the object. So therefore, acceleration attained by the object is taken to be as positive. So first case is body which is dropped from certain height. Let that height from the surface of the earth is equal to h. V0 is the initial velocity, let that be equal to 0 meter per second. Then g, the acceleration due to gravity, it is taken to be as positive. Why positive? The first case already I have taken the direction of motion and acceleration due to the gravity or the force which is exerted by the object, they are in the same direction. Or the other case you can take here, the initial velocity V0 is equal to 0 and as the object moves downward, its velocity also increases. So whenever velocity increases, acceleration is taken to be as a positive quantity. Therefore, the acceleration due to gravity g is taken to be as positive. Then we will see the equations. So already we have learned these three important equations known as equations of motion. First is v is equal to v0 plus at. Then s is equal to v0 t plus half at square. And last is v square is equal to v0 square plus 2as, wherein v is the final velocity, v0 is the initial velocity, a acceleration, t time and the other variable is s, that is the displacement. Now under the free fall, we will see what will happen to these equations. So we have seen that when the object is under freely falling condition, v0 is equal to 0. That is initial velocity will become 0. Therefore v is equal to this factor is 0 and that is equal to a. The acceleration and acceleration is replaced by g, that is plus g. Therefore plus g into t. Therefore the equation for velocity will be v is equal to gt and this is the first equation of motion when the object is under free fall and it is moving towards the surface of the earth. Then s is equal to v0 t now will become h is equal to this factor is 0 into t something is 0, this is 0 plus half of again g t square. So h is equal to half of gt square. We'll give the equation for relation for what? Height and acceleration along with what? Time. Then the third equation will become v square is equal to, first factor will become 0 plus 2g into s is nothing but the total displacement, therefore h. So v square is equal to 2gh. Similarly, there are equations when an object is thrown in the upward direction. So the object is lying there at the surface of the earth, then it is thrown in the upward direction. Now here the direction of the object is important. The object is moving in the upward direction. It has certain initial velocity with which it is being thrown. So as the object moves upward direction, the velocity of the object slowly decreases, and as it reaches a certain height, it will become 0. So therefore, the object's initial velocity is something, but the final velocity attained by the object will become 0. And what about acceleration? Here, the force of gravity is acting in the downward direction. The object is moving in the opposite direction. Therefore, the notation or sign taken for acceleration is negative. Or other way you can see, the velocity of the object is slowly decreasing, it is becoming 0. So wherever velocity decreases, acceleration of the object is taken to be as a negative quantity. Therefore, when an object is thrown upward to certain height h, the final velocity will now become 0 and g is taken to be as negative. Now these three equations will become v is equal to 0, so this will become 0. 0 is equal to something v naught as it is plus. Now their acceleration is what? Minus g. So plus of minus g into t. And this will become v naught is equal to, I have taken this minus g term, that side, so it will become plus gt. So v naught is equal to gt, the first equation. Similarly, s, now this is the h, v naught t as it is plus half of again minus gt square. Therefore the equation will become h is equal to v naught t minus half of gt square. Then the third equation will be, this is 0, so the factor is 0. V naught square as it is plus 2, again this is minus g into h, 2 minus g into h. This negative term again I have shifted over that side, therefore the equation will become v naught square is equal to 2gh. So these three equations which are there, they will give you equations of motion when the object is under free fall or it is under the effect of what? Gravity. So remember in that, check what is the initial velocity. Second factor, see whether acceleration is increasing or decreasing. And third is, since it is under the effect of gravity, replace A by acceleration due to gravity factor G. Then we will go with the next thing. Here it is. The Galileo, he gave one law which will relate distance travelled by the object. So the law is called as Galileo's law of odd numbers. Odd numbers means the numbers which are not divisible by 2. 1, 3, 5, 7, 9, 11 and all. These are all odd numbers. So when an object is moving, it is found that the object starts from rest, therefore initial velocity of the object is 0. The object is moving, so let us consider the displacement in terms of it is moving along the y-axis, so take the displacement as y. Therefore the equation, if I choose this, it will become y is equal to v naught t. V naught, this factor initial velocity is 0, plus half of, since it is moving along the y-axis, upward direction, this will become minus gt square. So this all we have learned about what? Freely falling effect. So half of minus gt square. Thus the displacement occurred by the object will be denoted by y naught is equal to minus half of gt square. Now we will see how the displacement of the object changes with the time. So let us begin that the time changes from what? Unit t. Means time is taken to be as 1. So when time is equal to 1, this factor will become half of g into 1. And let that be equivalent to 1 naught. So this factor is equal to 1 naught. Now go with your time t. If it becomes 2, then this factor will become what? So let us take the displacement y naught from this y is equal to y naught into t square, wherein y naught is the factor half minus half of g. Minus half of g, therefore. And this is becoming equivalent to, then the factor will be 4 times y naught. If this is 3, this is 9 times y naught. If this is 4, then this is 16 times and so forth. So we have noted down the values for y naught. And this is giving you the displacement made by the object, or the distance being travelled in an interval of how many seconds? 1 seconds. Now, if I take the difference of time interval, means 1 second, what is the distance travelled? After 1 more second, what is the distance travelled? How do I get difference of this? So, difference of this. So, here it is factor 1, here it is equal to 3, here if I take it is 5, then it is 7, then it is 9. So, I am getting what type of number? Odd number, 1, 3, 5, 7, 9 and so on. So, what he says, the distance being travelled by the object in equal intervals of time. The time interval with which the object is changing. Okay, it is under what again? Freely falling. And the condition is at the beginning it should be at rest. At the beginning it should be at rest. It is found to be changing by what? The ratios of what? Odd numbers. That is 1 is to 3 is to 5 is to 7 is to 9. Is the point clear? Then we'll learn about one more term that is known as stopping distance. So what is meant by stopping distance? Whenever we are moving along a road in a vehicle, let us take we are moving or riding a bike, and when we are moving, let us consider object comes under your path. So what you will do? You will apply brake, isn't it? And you will try to stop that and stop your bike. So when you apply the brake, what will happen to the acceleration? At the beginning it is maximum. Slowly the velocity decreases, means object's acceleration is decreasing. It will become negative, and that process is called as what? Retardation or deceleration, or the negative acceleration attained by the object. So slowly the acceleration decreases and the object will come to rest. So the distance being travelled when we watch the object or when we apply the brake till the object goes and stops. The distance travelled is called as what? Stopping distance. It is called as stopping distance. Okay. So after applying the brakes, how much is the distance the object travels? Okay, before stopping or before coming to rest, that distance is called as what? Stopping distance. If ds is the notation for stopping distance, then the formula for stopping distance is ds is equal to minus v naught square upon 2a. It is equal to what? ds is equal to minus v naught square upon 2a. Since the distance travelled is small, it is represented by d of s. V naught is the initial velocity, and so when you apply the brake, what was the velocity of the object? That is a V naught, and A is the acceleration. Acceleration here retardation occurs, therefore the sign what? Negative will come. The same equation is been derived from this. It has been obtained from the same. So final velocity will become 0. V naught square plus 2 of minus A into x. When we simplify this all, same formula we are obtaining. So directly I have given the formula for that stopping distance. Remember, the stopping distance is directly proportional to square of the initial velocity. Means when you apply the brake, the velocity of the object is very high, then you will cover larger distance. If velocity is less, within a short distance, you will stop the vehicle. Okay, and it is equal to square of the factor. Means if the velocity is 2 times, the distance travelled will be 2 v naught square. That is 2 square, almost 4 times the previous one. Is the point clear? Then the reaction time. What is meant by reaction time? Once we see the object in front of you, What is the time I take to react? React in that case is to apply the brake. So what is the time taken to analyze this? The object is there in front of you. Then tell your brain to stop the vehicle or apply the brake. So this reaction time, when you observe and when you react, the total time taken by the object, that is called as what? Reaction time. For a normal person, it is found to be equivalent to 1 upon 15 seconds. In a short period of time, okay, we will react for a given thing. But if the person is not in a proper condition, is disturbed, or he had taken alcohol, in that case the reaction time is large. So the reaction time is related with the factor of distance with acceleration. So T is found to be equivalent to root of 2 times V divided by G. So this is the distance divided by G. Acceleration due to gravity will give you the reaction time of the object under free fall. Is the point clear? So this is your time for a normal person, 1 upon 15th second when we react for something. So last concept of this chapter is relative velocity. Means when we are comparing velocity of one object with respect to other object which is moving along with you along the same direction or maybe moving in the opposite direction, then that term is called as what? Relative velocity. So how do I define relative velocity? So let us take example, that is two objects are there, A and B. They are moving along a particular line. Let us take the objects are two trains. The two trains, they are moving. At the beginning they are on the platform at rest. So there is no difference in the velocities of the objects. Then they start moving. They start moving with the same velocity along the same direction. So a person who is sitting here, he will feel that the second person in the second train is also at rest. It is also at what? Rest. Now after certain time, let the second train will speed up. It moves faster. So for the person who is there, he will feel that the person in this case, it is moving with certain speed. And whether that speed is equal to same speed as of the second train? No. There is some difference in the speeds. If this is moving with 40 km per hour and this is moving with 60 km per hour, for this person in this first train, he will feel that the second person is moving with the difference of the velocities, that is 60 minus 40, that is equivalent to how much? 20 km per hour. Means his speed, the person in the first case, he will feel that the speed of the second person is how much? 20 km per hour. So this difference in the speeds relative with each other is called as what? Relative velocity. So how it is defined? It is defined in this manner. That is relative velocity of an object A. This is the first object with respect to which I am finding the velocity of object B. It is equivalent to at what time rate of change of what? Position. So time rate of change of position is nothing but velocity. At what rate the velocity of objects are changing. That is called as what? Relative velocity of object. Okay. So let us consider the two cases. One is object A and object B, they are moving the same direction. So in that case, the relative velocity is obtained mathematically by taking what? Difference of the velocity. So just now I have said 60 minus 40. That will give you the relative velocity between the two objects. So relative velocity in that case, that is the relative velocity of object A with respect to object B. It is denoted as V of AB and that is equal to VA minus VB. So here the condition is A and B, they are moving along the same directions. They have velocities how much? VA and VB. So this is the formula for relative velocity. Other case we will take when object A is moving in the forward direction, B is moving in the opposite direction. So in that case, what will happen to the velocities? So here we will need to take into consideration the direction of motion. One is moving in the forward, other moving is in the backward. So we will take the notation negative for object which is moving in the backward direction. So the velocity will be again depending upon magnitude and direction. Therefore, to check the value, you need to take a negative sign for the velocity of the second person, that is for object B. A, it is moving in the forward direction, B, it is moving in the backward direction. They have velocities VA and VB. Then relative velocity is given by taking the difference of VA minus of VB. The velocity of the second will be taken to be as negative. Therefore, minus of minus VB and then will become plus VB. Thus, relative velocity of A with respect to B, the condition is they are moving in the opposite direction, is equal to VA plus VB. VA plus VB. Clear? Now we will see the graphical representations for these cases. First case we will take that they are moving uniformly with the same speed. In that case, the position time graph. Position is been taken along the y-axis, time has been taken along the x-axis. Object A had begun here, initial distance, and object B had this initial distances. Let this will be equal to x0 for this is the second object and this is x01 for the first object A. They are moving uniformly. If I take the ratio of x by t either for this object or for this object, it remains same. That is the velocities of the object VA for the first and VB for the second will remain constant. There is no change in the velocity. Then you are getting linear, parallel, straight lines. So these two lines are parallel with each other. And here what is the condition? VA is equal to VB. Let us take the second condition. The two objects among which one attains higher speed means take object A moves faster. So the ratio of displacement to the time will be more for it. So for that the distance covered should be more or displacement should be more. Therefore this is the tiltation and the other which is moving slower, this is the tiltation. So A is moving what? Fast and this motion is slower. So A to B, here B of A, that is velocity of A is greater than velocity of B and this is the nature. They are not joining at all, they are moving apart from each other, the lines. Then the third condition we will take, that is the object A is moving what? Slow and object B is moving fast. Or other case we will take, they are moving in what? Opposite direction. So opposite direction means A is here, B is here, they have certain velocities, they come and after certain time they meet and again they move apart from each other. So this is the case. A is having certain displacement and time t, it moves like this. B, it comes and its direction is like this. Let us take this the direction of A. They meet at certain time. So if I draw perpendicular, it will intersect your time axis at certain point. And whatever magnitude you get here, if it is 0, 10, 20, 30, then at 30th second after their motion, the objects will meet. And that time when they meet together is called as what? Time of meeting. It is called as time of meeting. So here the velocity of A is less than velocity of B. So VB is greater than VA. So students, in this chapter we have learned various important things. These variables are useful throughout the concepts of 11th and 12th standard. These variables are helping you to understand whatever things you observe around you. And we have seen the meanings, definitions of the variables. We have seen some important derivations for it. And then we have learned about some terms which we will come across in your day-to-day life. The numericals of this chapter we will see whenever we will begin with the regular classes, because at that time we will again recall whatever things we are learnt, and by taking into consideration that we will solve some numericals, because from this chapter one definite numerical will come. And this completes the chapter. motion in a straight line, that is the theoretical part of it. Thank you.